Okay, so now we're going to do the correct node equations for this problem. As you can see, I had my daughter draw this thing because it's much clearer than I can ever draw it. So that's where we're going with this. And this time I promise I will stick in everything we need. So once again, the first thing I do is I go in and I define the three nodes. VA in this case, I have 4 essential nodes. I'm going to make one of them ground, and there's that one I'm going to make ground. And remember, we're writing KCL equations in terms of Ohm's law, if at all possible. And the first thing I look for is voltage sources, and a voltage source, you could have multiple voltage sources, but it would have to be voltage sources only between 2 of my designated nodes. And I see the only place that happens is between VA and VB right here. So I need to write the equation for that supernode. So the supernode then is going to be, we look at this, and we're going to be swapping up and down here. So hopefully, well, there's the dog. So this is going to be the supernode equation in AB. And this is going to be the supernode. And this is going to be 0 equals VA minus VB. Don't blow through the node. Sign farthest away is minus 1 angle 0 degrees. Okay, so that is the supernode equation, or the equation for the supernode, I should say. All right, now then, the second VAB equation is going to consist of all the currents that come out of this supernode here. And as Robert pointed out, I left off the VC on the other video, which I chopped off and got that to work. So we're going to write the first equation. So coming out of VA, notice that this 3Vx source is in the same direction as my current. And so that's going to be 0 equals 3Vx. So here is the next VAB equation. And this is the supernode equation, and this is going to be 0 equals 3Vx, okay? Because it's in the same direction. Both my current and the current of the source is in the same direction, so it's plus. So then I'm going to have VA minus 0 and the sign farthest away, 3 angle 45 degrees. So here we go. Got to put that piece of the puzzle in. So this is going to be VA plus VA minus 0. Sign farthest away was minus 3 angle 45 degrees divided by 4 plus J3 ohms. All right, so that's 2. That takes care of this one, and it takes care of this one. So now then I'm going to go and do the VB equation. Okay, so I've got this current right here that goes all the way down to C, and then I have this current right here that goes also all the way down to C. No current sources, no voltage sources in there, pretty much straightforward node. So here we go, VB minus VC divided by 1 plus J1 ohms. So here we go. Where are we? Okay, keep on going with this equation. So this is going to be plus VB minus VC divided by 1 plus J1 ohms. And then I have the last piece, which is going from VB to VC, plus VB minus VC. Don't blow through the C node down there and go to ground. You can't do that. And I have a 2 ohm resistor plus the 6 plus J 1 ohm impedance. Okay, so there it is. This is a V, by the way. All right, so there's the VA, the VB equation. I need the VC equation. And if I look at this, the VC equation is coming out, and it is going in the opposite direction. So let's see if I can do this here. Ah, golly.